function of function. And this is not exactly same in the topic we discussed in differentiation. So it is the concept in integration. So this is not also called chain rule. Okay, in differentiation, we called this thing function of function or chain rule. But in integration, there is no chain rule. Okay, so the function of function is similar. That is why I use the same name, but maybe in books, in big integration books, you will not see this term. This term is not very popular. So here actually what I want to tell you, you already have the idea in differentiation that will help you to understand here. So let me just remind you, in differentiation, if you have something like ddx of sine 2x plus 1, in that case it will be a function of function concept, right? And what will be the answer in differentiation context? What will be the answer here?
Cos 2x plus 1
Yes,
into
so
2.
it will be, yes, it will be cos 2x plus 1, because you are considering 2x plus 1 as your
As
x,
x.
and then into
Dx of
there will be a
2
multiplication ddx of 2x plus 1.
2x plus 1.
So 2x plus 1 differentiation will be only 2. So it is finally 2 into cos 2x plus 1. This is the thing you get. So it is the concept in function of function for differentiation. Okay. There is no particular formula for this. This is actually one understanding, one situation, so that you can handle the situation by this technique. So in integration, you have the similar situation. Say I am now doing integration for sine 2x plus 1. So this is the function of function concept, and I am doing integration. So in the same way, you can think that 2x plus 1 is your x. So if this is your x, it will be sin x formula. So sin x formula will give you the answer like minus cos x. So in this case, it is minus cos 2x plus 1. So this is the first part. And then you need to do something with the x part. That is the portion you are thinking as your x. You need to take care of this now. Okay. So how it is possible? In this integration context, what you do the same differentiation. You do the ddx of 2x plus 1, same thing, ddx of 2x plus 1, but not multiplication. You will actually divide, you will apply division. So this is the difference. So in the next line you can get the answer minus cos then 2x plus 1, and for differentiation of 2x plus 1 it is actually 2, so you can write divided by 2. And now integration complete, so you put one constant, so your answer will come. Okay, so this is the function of function concept in integration. So this part we are doing an extra work, okay, as we are taking something as x. It was not exactly x, but we are doing something for that part as an extra work, and it is differentiation and it is division. So let me show you another example. It will be clear gradually. So let us take another example here, and I am doing integration, and this is function of function concept, and it is like, say, this is like e to the power e to the power, okay, 4x minus 3 dx, just as simple as this. So what to do? You will again consider that the power whole thing is your x. So if you think that this whole part is your x, then you can apply the integration formula, e to the power 4x minus 3, the same thing will come, and then you actually divide this thing by differentiation of 4x
X minus.
minus 3. So if you apply this differentiation and then division, final answer will be e to the power 4x minus 3 divided by just 4. And now you put one constant so that your answer will be complete. Is that okay? You understand what I say?
Yes, sir.
Yes, sir.
So let me show you another example that will be give you more clear idea on the topic. So I am taking another example now, and it is again say integration, and what I can write. Okay, so let us write like, or let me start again in the upper portion. Let me start from the left side so that I can get larger space. So this integration problem is with 1 u into v formula. Say this is 2x minus 3, then cos, then 4 minus x. This is my question. So it is UB formula, and then there will be something with function of function concept. So if you think about this question, 2x minus 3 will be your u, and then cos 4 minus x will be your v. So you apply the u into v formula first. So in the first line, this is just u into v formula, nothing else. So you apply the u into v formula like 2x minus 3 integration cos 4 minus x dx, and then minus integration, use one second bracket here. Okay, so within the second bracket you apply ddx of u, that means ddx of 2x minus 3, and then integration cos 4 minus x, that is the same thing, dx, and now you complete the second bracket and put another dx. So this dx, then complete the bracket, another dx, and move to the next line. So in the next line, you now do the integration, and you have the function of function concept, because this is not exactly x, it is 4 minus x. So this 4 minus x, this whole part will be considered as your x. So the first formula is integration cos x formula. So that will be sin x. So you will just write sin x. X means 4 minus x. And then you actually divide. So divide means you can just do it like this. Division, then the dx of 4 minus x. You can also do like this, right? Like this. And then minus the second part, integration. So what is the differentiation of 2x? It is only 2, and then 3 is just 0, and integration cos will be the same thing, like sine 4 minus x divided by d dx of 4 minus x. So in this case, in the next line you will write the answer, what is d dx of 4 minus x. So up to this it is all right. Move to the next line. So think about d dx of 4 minus x. What is the d dx of 4 minus x? It is minus 1, not 4.
Minus one.
It is for 4 it is 0, for minus x it is minus 1. That's it. So ultimately this is minus 1.
Only minus one, sir.
So exactly. So getting minus 1, you can put minus 1 at the beginning. So minus, then 2x minus 3, then sine 4 minus x. So the first part is finished. And then move to the next part. ddx will give you 1 minus, and you have another minus, so you can write plus. And then integration, then 2 sine 4 minus x dx, that will be the second part. So you can write the next line by doing integration. By doing integration for the second part. So what will be the integration of the second part? Again,
Again,
function
function of
of
function, sir.
function concept. So function of function concept will give you the answer like, let me write first plus sign, then within bracket minus cos another bracket 4 minus x, and then divided by d dx of 4 minus x. So it is actually minus 1. So you can write minus 1, no problem. So now integration complete. So you can put 1c, and then you write the last line, minus 2x minus 3 and sine 4 minus x, and then minus minus cancel. So there will be plus 2 cos 4 minus x, and then plus c. So this will be the answer for this question. Now try to understand. Think about this. This okay to you? Do you understand? Anyone has any question on this?
No, sir.
So this is another example, which is actually the function of function concept, and it is mixed with u into v formula.
Sir, can I ask one question?
Yes,
Not for this question actually. Sir, we
yes,
don't have any u by v formula in integration, isn't it?
yes. It is correct. There is no formula actually. That one is not included in this course. This is not the case. The case is there is no formula like u divided by v. Okay,
Okay, sir.
integration has only u into v formula, that is integration by parts. It is called not really called u into v formula, it is called integration by parts. So that is the u into v only formula. Fine, finish. And function of function concept is this. Now, is it okay? I mean, do you understand the uh, method we have just discussed here? Is this clear?
Yes, sir. Clear.
Okay. Now we need to know, we are not really learning the full of this concept. That is, function of function concept is clear to you, but how to solve the question, the technique I have now shown. So what is the technique I have shown? You will do the integration uh, in the beginning, and then you divide by differentiation of the x portion. So this is the technique we are applying for this question. It is okay, but this technique is not applicable for every situation. So I am showing one example. Say, for example, there is another question, and the question is, say for example, it is e to the power x square plus 4. So if it is the question, then if you apply the same technique, if you apply the same idea, like it will be e to the power x square plus 4, x square plus 4 whole part is the power. So this is the power, and then divided by d dx of x plus 4, sorry, x square plus 4. So in the next line, you can write it like e to the power x square plus 4 divided by 2x, and then plus c. This will be wrong answer. This will be wrong technique, wrong answer. It is not applicable. There is a restriction. It will not be correct. Okay, let me just show it to you first, and then I will cut it off. Okay, so this is another example for which the same technique cannot be applied. If you even apply, the answer will be wrong. It will not be correct. Okay. So why not correct? Because the differentiation of the substitution part, that is, which part you are considering as your x, originally it was not your x. So the part you are thinking as x will give you something with x, that is not a constant answer. The ddx of that part, ddx of that part will give you something which is variable, which has x, which is not only number. So if this is the situation, in that case, we will not be allowed to use the same technique. So this is wrong. It is not acceptable. Okay, this is wrong technique. Let me show you another example for wrong technique. Okay, so another example is, say we are doing something like integration and then root over uh, x cube minus 4x, okay, dx. So you can think x cube minus 4x, this is your x. So if you think x cube minus 4x is your x, in that case you can consider the x to the power half, and you can apply the uh, x to the power n formula. So if you think this is your x, then you can easily apply the formula x to the power half. So you will write x to the power, that means this full part, this thing to the power half plus 1 and divided by half plus 1. So that will be your integration formula. And for the extra part, you can use division and then ddx of that part only. So what is that part? X cube minus 4x. So in the next line, you can write, okay, this is x cube minus 4x to the power 3 by 2, and then divided by 3 by 2, and then it is also divided. Just let me write it with the division symbol, division sign. So what is the division, ddx answer here? 3x square minus 4. So my point is, if you see that the differentiation is giving you some result which has x, which is not a constant value, which has some x, so it is variable value. It depends on x value, so it is not always same, so it is not constant. So in this case, the idea or the technique we have discussed today, it will not be applicable. So we will write, actually for this case, this is wrong. We will write this formula is not appropriate for this situation, so it is wrong.
So then
Okay.
what to do?
Yes. So the thing is, this is two examples for which the technique we have learned today will not be used. So there are other techniques. In this function of function situation, there are other techniques, and those other techniques we are not really learning in this course. So for this course, these are not included. Okay, this and this technique will be something different. It is not really what we are learning today. So
So this kind of problem will not be in the exam. Yes.
exactly. So in the exam also, I will not give you something which is beyond your syllabus, what you cannot really solve, or what we did not discuss in our class. So that type of question I will not give. So you can be sure, okay, this type of question will not come in the exam. But for your understanding, I am just giving you the idea. If there is a variable or there is x in the differentiation part, in that case, this problem will be something different, and maybe you will learn some more integration techniques in other calculus courses. So for engineering students, maybe civil engineering, electrical engineering, mechanical engineering, only these three, they will have more calculus courses, and they will learn more integration techniques in other, examples or other type of things. So these two are two different types, and there are other things, other types. So you will learn in more advanced level calculus courses. So for this course, this is all right.
Okay, sir.
Okay.
Understood.
So is it okay? Do you understand what I say?
Yes, sir.
Everyone is okay with this?
Yes, sir.
So that is the
Yes, sir.
thing. Okay, so that is the thing actually I wanted to discuss today, and our class is finished. It is done. If you have question, then you can ask. Otherwise, class is done. So I will stop sharing this screen and I will go back to our classroom. Anyone has any question?
No, sir.
No, sir.
So you have copied the screen.
Yes, sir.
Yes, sir.
So okay, so let me stop sharing this now and let me go back to our original screen. Okay.